Hi, this is Atlas, and this is Understanding a Payloads Live, featuring Meterpreter and other guests. As always with my videos, the Who Am I slide. I'm Daniel Lopez Jimenez. You can find me on those my socials with those names, and I really enjoy studying and trying things for Windows and Active Directory security. And I'm also working at the company NCC Group as a managing security consultant. So what's the purpose of this presentation? The main goal is understanding the life of a Meterpreter payload, from the generation of the payload to the execution. The interesting thing about this is that even if it is targeted at Meterpreter, it's going to be, the knowledge is going to be really useful for any popular C2 framework out there. Okay, we're going to see why, but yeah, I can assure you that the knowledge is quite useful for all of them. And yeah, the idea of this presentation is heavily based on Rafael Match course, the Red Team Ops with Cobalt Strike. And in one of the videos in the weaponization, he explained the life of a beacon payload, and I was amazed by that video with all the diagrams and drawings and everything. And yeah, that video, among other things, are the reason of this presentation. So this slide tries to say what I said before. We're going to study Metasploit, and Cobalt Strike and other modern frameworks are different from Metasploit and Meterpreter, but not so different. Okay, so the knowledge we are going to see and we are going to study is going to be applicable to a lot of things. The agenda. We're going to see why Meterpreter was developed, a little overview of that. We're going to see common terminology about payloads, exploit, etc. And then we are going to move on into payload generation, payload executables, payload staging, and finally a little touch on reflective DLL loading or reflective loading. Okay, so starting with needing an advanced payload. Yeah, so let's suppose we have a memory corruption vulnerability, or we have the possibility to run a program on a victim host. So typically, if you wanted to have control of a victim host remotely years ago or decades ago, you would rely on native command interpreters for post-exploitation. So for example, I have a memory corruption, I write an exploit, and the exploit is in charge of running cmd.exe and to redirect the input to and output from into a TCP connection, which connects to my host machine, my attacker machine. Okay, so that has different limitations, and Meterpreter and payloads like that, like Meterpreter, were created as a better choice in these scenarios. So what are the limitations, or the main limitations, of native command interpreters? And this is not what I say, this is from Escape's white paper on Meterpreter. Escapes is one of the developers of the original Meterpreter, and the main limitations exposed in that white paper are, first, the presence of a command interpreter process. So if a employee of a company which only uses Microsoft Office suddenly starts cmd.exe and whoami.exe and so on, it's weird. It's not, it's suspicious. So that is a limitation in terms of operational security. Another limitation of command interpreters is that execution may not be allowed. There might be application restrictions policies in the host machine, like app locker, which may restrict the use of cmd.exe or powershell.exe, so you cannot use them directly. And finally, the commands or the functionality of these programs is limited. You can only use what you see, cd, ls, and so on. Okay, if you want to do anything else apart from the built-in commands, you would need to run another program, another process. So as such, the main goals of Meterpreter were, first, it must not create a new process. When you run Meterpreter, you don't need to create a new process. Okay. Of course, if you are running a Meterpreter payload from a exe that you are writing to disk, yeah, that's going to create a new process. But you don't have to. If you have a memory corruption vulnerability, you would run Meterpreter within the service process, okay, without running any new process. Meterpreter must work in restricted environments. This is very much associated or related to the first point, because if we are not running a new program, then, or a new process, sorry, then application restriction policies have limited action on the execution. Okay, if we run CMD, we are creating a new CMD process. But if we run a Meterpreter shellcode or payload within an existing process, then things like app locker doesn't work well, protecting that. And finally, Meterpreter must allow for robust extensibility. So this is related to the limitations on command interpreters, where if the built-in commands don't cover what you need, you have to run more processes. In Meterpreter, you can use extensions, and we are going to talk more about that. So yeah, the Meta Interpreter, which is the original name of Meterpreter. It is a command interpreter and remote access tool, so you can use it to control a remote system. It is designed to be a payload, and again, we are going to talk more about this throughout the presentation, but what we can say is the payload, the Meterpreter, can be run without touching disk. This can be run from memory, and it is suitable for memory corruption exploits and other attack scenarios. And finally, yeah, we can use Meterpreter extensions to extend the capabilities of a Meterpreter session without creating new processes or touching disk. So Meterpreter is integrated within the Metasploit framework. Meterpreter is the server. When you run a Meterpreter agent on a victim host, Meterpreter is the server and Metasploit is the client. Metasploit is the one sending all the commands and tasks to be executed by the server, which is Meterpreter. It is multi-platform and multi-architecture. You can find different flavors of Meterpreter, like written in C, PHP, Python, etc. But we are going to focus on Windows Meterpreter, which is written in C, C++, assembly, and Ruby on the Metasploit's side. So what are the main components of Meterpreter? The main components are reflective DLLs, and this is the reason why Meterpreter can be run from memory instead of needing to write it to disk. So reflective DLLs, we are going to be talking about them all the presentation, are a specific type of DLLs which can be loaded from memory. You don't need to write them to disk. Okay. So the main component, the main reflective DLL in Meterpreter is called MetServer. MetServer is in charge of communicating from the victim host to Metasploit, to the attacker machine. But it is also in charge of loading new extensions and more stuff. Okay, so MetServer is a very small program, and it doesn't provide much in terms of post-exploitation capabilities. For that, we need the other extensions. So in terms of extensions, we need to know that they are, of course, more reflective DLLs, and they are loaded as modules to the Meterpreter session to expand the commands and the capabilities. Okay, when you load a new extension, you are not creating any new process or writing anything to disk. It's all done within the memory of the process where Meterpreter is running. Some examples: the STD API, which is intended for interacting with the operating system and the file system, with providing commands like change directory, list directory, netstat, and so on. The extended API, which provides support for interacting with WMI, etc, and things like that. And yeah, there are quite a few of them. For example, Kiwi, you don't have to upload Mimikatz to the victim host. If you are using Meterpreter, you can load the Kiwi extension and you will have all the Mimikatz functionality without creating new processes and without writing anything to disk. So extensions, if you install Metasploit, the Metasploit framework, and you go to this folder, the data Meterpreter, you will find a number of precompiled DLLs which correspond to the extensions. Okay, they follow the name ext server name of the extension .dll, and you will also see another ones which are related to a specific extension. So for example, elevator.dll includes different techniques for privilege escalation, and since it's quite a big enough program by itself, it's that's the reason why it's on a different DLL. So you can load the priv extension and then it will leverage the elevator reflective DLL separately. Okay, so the picture of a Meterpreter agent or a Meterpreter session is something like this. We have our attacker machine where Metasploit is running with a listener, and we have the victim machine where we have executed a Meterpreter payload, and then we will have one process where the code of Meterpreter is running. The Meterpreter code is going to have as a minimum MetServer, which is the core component. MetServer will be interacting or communicating with the attacker machine, establishing the session. And then, depending on how we have configured the payload, we may have one or more extensions. Okay, so before moving on onto the Meterpreter is so noisy, we are going to see a little bit of Meterpreter in action. Okay, here we can see Metasploit 6, and we can see I have one Meterpreter session on the Windows WS workstation 01 machine. I can go and interact with the session, and if I run help, we see a lot of here we can see core commands, std API commands, priv commands, external API commands. So these are different extensions, okay? By default, if you configure Meterpreter to only run Met server, you will only have the core commands, which, as you can see, they are mostly related to the communications, to loading extensions, for example, load extension, load one or more Meterpreter extensions, and so on. But if we move to another one, the std API, we can see common interpreter, common cell commands. Read a file, change directory, copy a file, delete a file. Networking commands to see information about the ARP cache, etc. System commands to execute other processes or reboot the machine. Okay, priv to extract credentials. So yeah, when we run commands like these ones, get UID to get the username of the process where we are running the session is associated to this user capsule /yamcha. sysinfo, we can check information about the machine, WS01. We can list all the processes, a lot of information. And yeah, we run new extensions, example, the external API, which is already loaded. Everything we are doing is not going to open any new process or writing anything to disk by default. Okay, so yeah, we can do a lot of stuff more than a native common interpreter like CMD, and yeah, it's really handy. Okay, so yeah, now the big question, the elephant that that everyone sees actually. Meterpreter is so noisy. Well, yeah, if you run Meterpreter by default and Metasploit payloads by default, everything is going to be blocked by AVs and detected by EDRs. And even if you happen to execute and achieve a Meterpreter session by somehow, then if the security solution performs a memory scan with Yara, for example, it can easily spot a Meterpreter agent. So yeah, that's true. And we should be aware of first that Meterpreter was created with the main goal being better than traditional common interpreters, okay? And of course, with the rise of EDRs, AVs, and so on, evasion is now a problem or a challenge, let's say. Okay, and we can see here Spencer, which is a developer of the Metasploit framework, one of the members of the team of the Metasploit framework. It talks about how evasion has always been a problem for Metasploit and will remain a problem for the future, the near future. Yeah. Designing, So yeah, I wouldn't talk about this as a problem, and that's why one of And this is one of the reasons why I started doing this presentation. So, of course, we cannot run Meterpreter by default without changing anything, because nowadays, as I say here, it is virtually impossible to use public tools right out of the box. Okay, and that includes Meterpreter. So we need to adapt. We can't go like a child and download a tool that everyone can see the source code and pretend that it bypasses everything. Okay, so yeah, we cannot use Meterpreter as of today to perform a security assessment without changing anything. We cannot demonstrate impact, we cannot assess efficacy, and we cannot train anyone with this. Okay, because we're going to write our executable and it's going to be deleted. So yeah, the goal, one of the most important goals of this presentation is for me to say, don't give up on great tools just because they are detected by default, okay? And try to adapt. Try to understand why they are detected and how you can modify them to avoid those detections. At least the automated ones, at least the signatures, the most easy signatures which detect those payloads. Okay, so yeah, this is going to be an adventure on understanding how Meterpreter, the different phases or the different things we need to consider when trying to understand the life of a Meterpreter payload. And yeah, it's going to be useful for if you want to change those things afterwards. So now I understand how a Meterpreter payload is generated. What can I do to modify that generation? Now I understand how a Meterpreter payload is inserted into a payload executable, executable recipient like an exe. How can I modify that executable recipient to bypass or to avoid silly detections? Okay. So yeah, and as a final point, it doesn't matter if you don't use Meterpreter or won't use Meterpreter ever. I think it's going to be interesting to understand these things for Meterpreter to extrapolate towards other tools. Okay. So yeah, this is the agenda, but as a picture, the payload generation, which is the first section we are going to see, is this one. So Metasploit, when we generate a Meterpreter payload, is going to generate a cell code. Then we can insert that cell code into a executable recipient, or we can use that cell code via an exploit. Then when that payload or cell code is executed, there might be a staging process. Okay, that is optional. But if everything goes well, then the Met server reflective loading process should be started, which should end up with a Met server program running within the process, the affected process. Okay, and then you should get a session. From here, you can, depending on the configuration or what you are doing, you may load further extensions via reflective loading. Okay, so yeah, the main sections of this presentation: payload generation, this one; payload executables, this one; payload staging, this one; and finally reflective loading, this one. Okay, we are going to understand each of them. So before starting with the generation, let's talk about key concepts and key terminology that everybody should know in this area. So first, the difference between exploit and payload, because they are often used like they are the same thing, but they are not. So when we talk about these terms in a vulnerability exploitation, they are meant to decouple the process of abusing a vulnerability, which is the exploit, and then the thing or the code that is executed after you have abused that vulnerability, okay? The payload can be a lot of things, okay? I may run an exploit to execute a payload that creates a new administrative user on the target machine. Or maybe the payload can be a MeterPreter session. Or maybe the payload can be running a ping to our Metasploit client to say, hey, this is indeed the exploit succeeded, but I don't want to do anything else. I just want a ping to say, okay, it worked, and that's it. So payloads can be different things. The exploit you can develop with in different ways, but yeah, you are exploiting a vulnerability, a specific vulnerability. Okay, so more or less is something like this. I'm always using the slingshot, or I don't really know how it is called in English, to be honest, but I'm using this tool, and I can throw a rock, or I can throw anything else. I can throw an egg if I want. Okay, so that's more or less the difference. We're going to be focusing on payload being cell code. Okay, so if we talk about vulnerabilities like web vulnerabilities, SQL injection as an example, a payload can be SQL code. Or for a cross-site scripting attack, a payload can be JavaScript code. But for this presentation, we are going to be talking all the time payloads being cell code, okay? Which is, cell code is a sequence of bytes that represent assembly instructions, all right? So yeah, we will stick to scenarios where you can execute cell code in memory, like vulnerabilities, or situations where you can run your exe, and your exe, what it does is running a cell code, okay, or process injection, for example. So Meterpreter and a lot of Metasploit modules can be run from memory because of the reflective DLLs, as I said before. And this is because why everybody uses reflective DLL injection, because reflective DLLs are easy to develop as opposed to writing cell code directly. And you can use the same method. So reflective DLL injection can be used for any kind of tool. Okay, so you can have a reflective DLL for Mimikatz, a reflective DLL for other tools, and all those reflective DLLs can be executed with similar methods. So it's really interesting for an attacker to have your tool set. Okay, so what is reflective DLL injection? It is a technique that runs or loads the DLL file from memory, okay, and can be extended to exe files, which is then called reflective PE injection. Okay, so this technique was not created by the Metasploit team or anything, okay, and is not specific for Meterpreter or Metasploit. It is used by most of the modern command and control frameworks nowadays. Okay, so this is because reflective DLL injection is handy, as I said. So what's the difference between Metasploit and Meterpreter and other modern frameworks? Well, the modern frameworks are usually focused on the evasion side of things. So even if they use the same technique, it's implemented in different ways to bypass common detections for reflective DLL injection. So here you can see how Metasploit uses a fork from the Stephen Feuer's reflective DLL injection repository. Okay, so it's very, very similar with a few modifications. But you can also see how frameworks like Cobalt Strike use reflective loading, okay, in the same way, but with those additions we mentioned. Brute Ratel uses reflective DLL injection for its main agent. Nighthawk uses reflective DLL injection for the main agent. And Havoc can also use reflective DLL injection if you want to run the daemon agent as cell code. Okay. So yeah. So reflective DLL injection is used by everyone, and even if it appears like a really outdated technique or something like that, it is not. It is being used by everyone still nowadays. And as an interesting fact, the reflective DLL injection we are talking about has been used by Metasploit from 2008 onwards. Okay, Feuer's technique. But before that, Metasploit did use, or Meterpreter did use, another DLL injection method, which you can find it today as patch up Meterpreter. Okay, that technique was developed by Escape and JT, as HD Moore explains here, and you have more information about this technique in the link, remote library injection. But yeah, it uses, instead of trying to implement DLL loader as the Feuer technique does, this technique, if I recall correctly, used hooking to load a DLL using the Windows API, but trying to remove the requirement for the DLL to be written on disk. Yeah. So introduced in 2004 by Escape and JT, their technique employs cell code to patch the host process's NTDLL library at runtime and forces the native Windows loader to load a DLL from memory. So yeah, it's another way to do it. And that's it for the first video. I hope it has been interesting for you. And for the next one, we are going to start with payload generation. Thank you very much. Bye.